Hello everyone, it's Benny, and in this video we're going to be adding textures, real textures, into our game. Now this all starts with your choice of Wolfenstein 3D textures. As I explained in the FAQ video, I do not have a copy of Wolf 3D anymore, so my solution is to go into Doom 2 and use Doom 2 textures. And I'm going to go ahead and show you how I did that. First off, I used this program called Slate 3. It lets you read Doom 2's data. So I just opened doom2.wad, the Doom 2 data files. I searched for Wolf, and here are all the Wolfenstein 3D textures. What I did is I took these, I copied them, created a new WAD, and by the way, this is just in case you want to follow along and get exactly what I did, and I pasted them. The reason I did this is because you can't edit the textures in the actual Doom 2 data. And then from here, I converted them to PNG 32-bit, converted everything, then I right-clicked, and I exported, saved to desktop, and etc, etc. Now, there were actually two more textures I got. I'm going to see if I can find them. This one right here, and this one. Those were flat something or other. I'm going to see if I can find those for you guys. So flat, and I know it's in here somewhere. Flat 5_4, that's one of them. And the other one, it's a little castle thingy. Okay. Well, I don't remember exactly, but it's that castle floor thing. I'm sure you can find it if you search for Doom 2's data. But the grayish one is flat 5_4. Same thing there. Copy it over and export it. From that, what I did is I opened up all the textures in an image editor and compiled them together into a 512 by 512 image, which looks exactly like this. I did not use all the Wolfenstein 3D textures, as you can see, but I did use a fair number of them, and this is the final texture I came up with. Again, I'm not going to assemble that on screen. This is just for people who want to have exactly what I had. So here you go. I can't distribute this because all these textures, to my knowledge, are copyrighted, and, well, there you go. If you want to use your own textures or something, you can do that, but this is how I assembled my textures. This is how I got my big texture that I called wolfcollection.png. You can do that if you want, or you can put together your own thing. Either way, there you go. So, to start off with, I'm just going to replace our test with the wolf collection. All the textures that our game is going to use. So if I run, now I get the textures just plastered all over the place. And it looks probably even more chaotic than before. And you also notice all our wall textures are upside down. So this is going to be a little bit interesting, but it should be alright. So, here's what I'm going to do. I'm going to create texture coordinates, real texture coordinates. And here's how this is going to work. I'm going to have the green component of my texture coordinates be the floor texture. So like the first 16 will say the first texture, the next 16 colors in the green component will say the next texture, and so forth and so on. And maybe I can do something with those intermediate 16 values that can do something. But yeah. So, to start off with, I'm just going to create int text x and int text y. These are going to be integer coordinates which represent the actual texture that I'm going to get. And as I said, this is going to be the red, green, and blue components, so... Well, no, not the red, green, and blue components, just the green component. So text x, I'm going to start with level.getPixel I, j. And I'm going to do a bitwise and 0x00ff00. And that will simply get me the green component. Because ANDing it like this gets me RG and B, so nothing on red and nothing on blue, right here, just leaves me with green. So, there we go, I got that. Now I'm going to shift it left 8 places. So, a full byte essentially. And that gets me into a slightly interesting position here, but it should be okay. So that should get me at least enough to calculate the y-coordinate. Here's the thing. Once I've shifted this over left, then essentially I just have whatever the green component is from 0 to 255. Like I said, I want this sort of be done by 16, so 0 to 16 all maps to the first one, 16 to, well, I guess 17 to 32 maps to the second one. Maybe not exactly like that, but, you know, general idea. So what I'm going to do is I'm going to divide this by 16. That way, that should get me whatever the appropriate x-coordinate is. So, well, it shouldn't give me the appropriate x-coordinate. It should give me which texture from 0 to 16. It won't give me improper x-y coordinates, which is what I'm ultimately going to be going for here. But this will just map the whole green component from 0 to 16, which is good. Now, in order to get the y component from here, from this point where I just have all the textures from 0 to 16, or well, I guess technically 0 to 15, but you get the idea. So, texx modulus 4. That's how I'm going to get the y component. So it's just going to be y texx modulus 4. Well, keep in mind, modulus, that's sort of the remainder after division. If my texture is, say, I don't know, if I'm at 12, well, that's going to essentially, the way I'm going to be mapping is I'm going to be, actually, where's the texture? I'll just show you there. The way I'm going to be trying to map it is so that, like, this is 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's the way I'm going to be trying to map it. So if I'm at, say, texture 12, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, well, the remainder after division is 0. As you can see, it's on row 0, so that's the appropriate y-coordinate. If I'm at, say, texture, I don't know, 9, 1, 2, 3, okay, 8, 9, right there. Wait, what? No. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 right here. Remainder 1, so it's on the first row. See, works like that. Finally, all I have to do is get my x-coordinate into the appropriate, well, x-coordinate. So what I'm going to do is I'm just say texx divided equals 4. And what that's going to do is, for example, I'll go to 9, so I'm right here. I've got my y-coordinate. Now, 9 divided by 4 in integer division, that's 2. And so 0, 1, 2. So as you see, that gets me appropriate xy coordinates. And that's exactly what I'm going for here. So great. That will give me, well, the appropriate xy coordinates here. Now, before I go ahead and use these variables to calculate whatever the appropriate texture coordinates are, what I'm going to do is I'm going to create constants for these. So that way, hopefully, it's a little bit easier to change the total number of textures later on if I need to for some reason. So, what I'm going to do is I'm going to create a private static final. It's going to be an integer. I'm just going to call it numtexx for numTexture exponent. And it's going to be equal to 4 for now, because we have 16 total textures, and 2 to the 4th power is 16. Why am I doing it like this? Well, that'll be explained in the next constant, which is private static final int numTextures. And that's going to equal math.pow 2 to numText exponent. And of course, I'm going to cast the result to an integer. Wait, what? Oh, that makes more sense. Integer. And with that, it's not used, that's fine. And you see, this will raise 2 to whatever the exponent power is. So if this is 4, this will give me 16 total textures. If this is 5, or if this is 5, it'll give me 32 total textures. And, you know, it just makes it nice and easy, since I'm always going to end up with an exponent of 2 in number of textures. So there we go. Now, I've scrolled down way too far. I'm going to divide this by number of textures, and I'm going to modulus this by numText exponent. And same here. So there we go. That's going to make it just a little bit, not a whole bunch, but just a little bit easier whenever we're actually, going to be doing this. And with that, let's calculate our texture coordinates. Here's the thing about our texture coordinates. Our texture coordinates are in the range 0 to 1, but our xy coordinates are from 0 to 4. So we're going to have to do a bit of conversion. And here's sort of how that's going to work. Right now, I'll stick with number 9 as our example, texture 9. This has the coordinates 2 on x and 1 on y. So this is 2, 1. In order to get the higher coordinate, I'm going to want that to be 0.5, because it's going to be right here. Well, the higher coordinate for x, but right here, just so you know. And here's the thing. I want this to be 0.5, of course, but to calculate that, I'm going to have to somehow convert my x coordinate, which is 2, into that appropriate value. And here's how I'm going to do that. I'm going to take my tex x, so whatever that is, cast to a float, and I'm going to divide it by, cast to a float, num tex exponent, which would be the total number of textures on any given axis. So essentially, in this case, that'll do 2 over 4, since 4 is the total number of textures on one axis. And that gets me, guess what? 0.5. That's correct. The problem is this isn't the best example texture, because if I do, say, texture 12, well, that's 3 on x. And 3 over 5, that's 0.75. 0.75 is, well, way over here. So what I actually want is I want 1 minus this. And that will give me proper high x coordinates every single time. Now for lower. For lower, that's actually a little bit simpler. What I'm going to do is I'm going to take my higher coordinates, so x higher, and I'm just going to subtract 1 divided by float num tex exponent. I'll do 1f. And you might be wondering what this is doing. Well, 1 over num tex exponent, that's going to be, for example, in this case, since num tex exponent is 4, 0.25. That's the total distance in texture coordinates across a texture. So, for example, in this, it's getting me this, so it's saying my lower coordinate is this minus the distance across a texture. See what it's doing? So since I already have the high coordinate, if I subtract the distance across a texture, that places the low coordinate right at the start of the texture. And that's how I'm calculating texture coordinates. So now for y higher and y lower, I'm going to do the exact same sort of thing, except for, well, I'm going to be doing it with the y value. So, tex y, and here, it's going to be x, y higher. Almost confused myself there for a second there, but yeah. And with that, this should be placing the whatever the floor texture is on absolutely everything. So, this should be fun. Let's see what happens. If I run, hey, we're getting some sort of texturing. In fact, one of the interesting things here is all of our textures are actually upside down right now. So, yeah, what we're going to want to do is we're going to want to adjust our texture coordinates a little bit so that, well, we don't have upside down textures. Now, the way I'm going to do this is I'm simply going to reverse y higher and y lower. So, just like that. And that should fix the upside down issue. Excellent. Now you see our walls are right side up, and our floors look, well, they look right now. So good. Now we have proper texture mapping. But you might notice a slight issue. What you might notice are almost sort of like lines going through the floors and things. What's all that about? What this actually is a filtering issue. And the reason this is because right now I'm doing this texture for instance, in order for it to render this texture, it's sampling the textures to the side of it. So it's like sampling 1 pixel from this texture and 1 pixel from this texture, etc., in order to generate the final texture. The way you traditionally would overcome this is by having a 1 pixel layer between every single texture, so that when it actually filters it, the 1 pixel it goes out to get for filtering is still a valid pixel. However, since I'm doing sort of an 8-bit game clone, I have a better way to solve this. And unfortunately, this will require me modifying the engine code. Oh, wait, what? Oh, I'm in the completely wrong file for some reason. Never mind. Okay, so now, if I go to my texture, what I can do is I can actually pass something else in when I say get texture. And I want to make sure I'm... Yeah. And... yeah, right here. What I can do is I can pass in GL nearest. I can tell it what sort of filtering I want to use. And nearest filtering not only will solve the problem since it's not doing the filtering thing, but it also gives it more of that 8-bit graphic feel. Because, well, technically these are 8-bit graphics, we're just encoding them as 32-bit graphics. But yeah, so there we go, we've got nice texturing going on, at least on one front. Here's the other thing about our textures. Although we do have proper texturing going on, this will select things, and we could theoretically change the green component and make things do things. One thing we're missing is right now it's mapping the same texture just everywhere. And I want individual control over what the wall texture is. So I'm going to copy this code, and I'm going to move it to right above where I do generate walls. And I'm going to change our texture coordinates. I'm going to recalculate them. And what I'm going to calculate this based on is, rather than, say, the green component, the red component. And there's going to need to shift over 16 this time. And now this should give me proper textures for the walls based on the red component. So now if I run, it should do exactly the same thing for now, but now it should be sampling from the red component. And it's at this point that I would like to open our, not this, that I would like to go into our level and actually test this out a bit. See if I can get, you know, something interesting going on. If this ever opens. There we go. So, while I'm at it, I'm going to... No, I don't want to install a new version right now. I'm recording a video, thanks. But, what I'm going to do here is I'm going to first off zoom in. And, second off, I'm going to... Where's the pencil tool? Did it just... Oh, no, it's over here for some reason. Okay. Now let's choose which texture. Oh, I don't know. Let's have some bricks for the walls. Why not? So I'll have bricks for the wall. Well, you know what? Let's leave the walls as they are for now. Let's just change the floor to texture 0. So, the way I'm going to do this is I'm going to sample my current white pixel, and I'm going to change my green component to 0, since that's the floor. I'm just going to use paint bucket and fill all. And save. Sure, should be fine. And let's run and see what happens. And hey, look at that! Our texture mapping systems is working. It's picked up on the fact, hey, whoops, you want to change the floor and ceiling, so there you go. So cool. Not only does it appear to be working, but we appear to have texture mapping. And just to be sure, I'm going to open Wolf Collection in this. I'm going to pick something else out. I'm going to pick out, texture 2. So 32, that's going to be my red component. And let's have that. So texture, that's 2, 3, 4, 5. So 5, and 5 times 16, I believe is 80. So now that's my new texture. Save. And you can paint stuff in. I'm just goofing off, really. And what do you know? We have proper texturing, just as we wanted. So, there you go. That's how you get texturing working. We can now texture our level. And I'm actually going to change it back because I liked it better the other way. But yeah, we can not only load in what textures we want, but we can paint in what textures we want in the level. And theoretically, you don't have to use these same 16 textures for every level. You could load different textures in based on level and choose it like that. Either way, point is, we can now choose which textures we want in the level file, load it in, and our game will draw it with the appropriate textures. And that's awesome. So, I've rambled on way too long. Thank you. Hope you enjoyed. Hope you learned. And see you next time.